Hello, this is Peter from Educomondo and a warm welcome to our 6th STEAM project, Teacher Edition, called The Battery Billboard. This series of lessons is for the absolute inexperienced STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. The goal of this lesson is to teach your class how to control the on and off switching of multiple LEDs in a consecutive way. And secondly, to introduce smart programming by using some logical thinking and basic math. This will allow the program to be shorter and eventually run faster. Here is our project board that by now should look very familiar to you and your students. If it doesn't, go to our previous lessons where we explain how the microcontroller, the breadboard, and the Arduino IDE work. Here is the drawing of the project that you and your students are going to build. You can leave this image on your laptop, or if you have a beamer, project it on the wall. Time to hand out the required components from the STEAM starter kit. 5 red LEDs, or light emitting diodes, 5 resistors of 220 ohm. If you are not sure about the value, check it with the included reference card or measure it with either a multimeter or a component tester. We will need 6 jumper cables. Because we need so many, we will use all the colors that we can find. We will also need 5 small preformed cables to connect the minuses with the ground rail on the breadboard. And let us not forget the most important part, the cardboard battery. The setup will be pretty much the same as the traffic light, but instead of 3 LEDs, we have 5 LEDs of the same color. Let us put the LEDs in place according to the drawing. Remember that LEDs are sensitive to their polarization. The long leg is the positive leg where we will connect the resistors. Make sure you are not mixing the positives with the negatives. We mount all 5 LEDs in such a way that they form a nice row, not too close, not too far apart, because the cardboard figure has to fit over them. Next we mount the 5 resistors. Each LED requires a resistor. The resistors are connected to the long leg of their respective LED. We will use the small preformed cables to connect the LED's negative legs to the ground rail. Next, we are going to connect the LEDs to the Arduino. Each of the LEDs will need a digital pin to receive the command to go on or off. So we can connect to whatever number we want. However, it is recommended not to use pins 0 and 1 because the USB port of the microcontroller uses these pins to upload your sketch. The first LED goes into pin number 2, the second one goes into pin number 3, the third one goes into pin number 4, the fourth one goes into pin number 5, and the fifth one goes into pin number 6. The black cable is used to connect to the ground pin. Because we are using more and more components, it becomes increasingly important to work in a neat way and not to have too many loose cables. With the preformed cables, you can make really nice and neat connections. Once you have checked with your class that they have built the project, connect your project board to the computer and check whether all LEDs are blinking. Next, click on the Arduino icon and create a new sketch. Because we want to teach good coding practices, we first give our file a name, and we do that in the space above the void setup. We will call this file Project 6 Battery Billboard. We want to ensure that the Arduino program does not interpret this as a code, so we put a double slash in front of it. Now the Arduino knows that whatever comes after on this line is a comment. Comments are important because it will help you and others to remember why certain things were added in the program. Let's pause for a moment. We have 5 LEDs, so we need to define all of them as an integer. We could do this for all of them separately, but we can be smarter and let the program do it for us. We only need to define the first LED pin, and we will call that the base pin, because we will start our calculations from that. It is our basis. So we type int for integer, base bin equals 2. And don't forget to close with a semicolon. Now we have to tell the program that we have a total number of 5 pins. That total is also declared as a variable, and we call it numspin. Integer numpins equals 5. And we also create a variable of which we don't know the value yet, as it will be a variable that is calculated and will change value all the time. We call this variable j. It is an integer, so we type int j. Because the microcontroller is such a fast device, it is always useful to already define a delay variable in milliseconds. int dt equals 200, semicolon. In the void setup part, we activate our pins one by one, starting from our base pin on 2 by using the for command. So we type for, and in between brackets we use our variable j, and we set it to equal base pin, and for as long as j is smaller than the sum of base pin plus num pins, the system will add 1 to our variable j. J equals j plus 1. And while it is doing it, it has to create a pin mode, and it creates an output to j. In the void loop part, we run the actual program, and once again we use the for command. For j equals base pin, And for as long as j is smaller than base pin plus the number of pins, we will add +1 to j. And what do? We send a digital write where we set j to low. And this will turn off the LEDs one by one. And here we also put a delay in place. We do the same for setting the pin high, so for the integer j equals base pin, and for as long as j is smaller than base pin plus the number of pins, we will add 1 to j, and it will set the digital write to the pin j at high, and it will turn on the LEDs one by one. And also here we can end with a delay dt. By using a for loop and combining multiple variables, we have written a short and smart program. Yes, we could have written the program using separate pin modes and digital write commands, each time using the delay function, but that would have been a very long program. With some logical thinking, we have made this code shorter and smarter. But, of course, the big question is, will it also work? Let's find out and upload the program to our microcontroller. Congratulations if it also works for you. Great job! If not, no panic. Do some logical fault finding. Did you end all commands with a semicolon? Did you type all commands correctly? Arduino has some strange ways of writing commands with upper and lower cases in the word. Did you put the wires in the right pin? Did you declare the right pin number as a variable? Are all connections on the breadboard firm? Is the LED not broken? This concludes our 6th project, the battery billboard. We learned how to make a more complex build with multiple LEDs, applied the for loop, and we did some error and solution finding. Because we experimented with batteries, wouldn't it be a great idea to have an assignment involving battery technology? Here are a couple of questions you can ask your students to do some research on. There are many battery types. Can you find 10 examples and explain the difference between them? Ask your students to research and explain the basic working of a battery. Can they make a potato battery? Why is it important to recycle batteries and not just throw them in the bin? And why is there so much focus on electric bicycles, motorcycles and cars? Can you find out how they are powered and how they work? Have fun with the assignment. I enjoyed this project very much and I'm eager to start with our lesson number 7. In that lesson we will introduce a new component, the active buzzer. In our future projects we will be able to make some noise like a buzzing bee. Bye bye for now.